All right, so we had solved it this far. I have done the simplifications in green for you guys, and we just need to remember, slightly recall what our original expressions did look like. So we had this, and it was adding with this, and we had to give this expansion up to and including the term x square in ascending powers of x. All right. So if we put that in, we get minus 2, and then we have this particular expansion because that was what 1 upon x plus 2 basically. So that's 1 minus x upon 2 plus x square upon 4. Then we have x plus 4, and that's going to be multiplying with, well, I know here it looks like it's dividing with x squared plus 4, but what we expanded wasn't x squared plus 4. What we were expanding was this 1 plus 1 upon 4 x squared raised to power minus 1. So now you add this, you have, what do you have? You have x plus 4. This is being divided by 4, and this is into your particular expansion, which is 1 minus x squared upon 4. And I'm running out of space here, but let's use a different color. Okay, so, and basically what you do now is you just simplify. The only thing to take care of is that when you multiply this particular bracket, when you multiply x with x squared, that will give you x cubed, which you can just ignore because you just have to give it in ascending powers of x up to x squared. So let me just do the simplification. All right, there you go. Just one thing I realized when I was expanding this is that if this wasn't in fact minus 2, this was minus 1. Why was that? If you look at it here, if you recall what we did here, when we were standardizing it, trying to take 2 common, we had cut 2 in the numerator with the 2 that we had taken common in the denominator. So I forgot about that, but I caught it when I was just expanding. So I mean, obviously, if your working is neater than mine, which it should be in the actual paper, hopefully you won't make silly mistakes like that. Okay, so question 10. Let's try to wrap this up quickly. The diagram shows the curve y is equals to ln x square. So note, this is not x square, this is ln x whole square. The x coordinate of the point P is equals to E, and the normal to the curve at P meets the x-axis at Q. So what is the normal to the curve? The normal is basically the line at that particular point that forms a 90-degree angle with your curve. It's normal to it. And they're saying that it meets Q, the x-axis at Q, and obviously the coordinates for Q would be, there will be some value of x and 0, because y is going to be 0 at at any point on the x-axis. Y would be 0, right? You have to find the x coordinate of Q. How do you do that? You first differentiate. You get 2 ln x. So this was the power rule, power shift, power subtract, ln x into internal differentiation. Internal differentiation would be 1 upon x, because if you differentiate ln x, you get 1 upon x. So here you get 2 over x ln x, right? And you're trying to find the gradient here. And what you'll do is, since you're trying to find the gradient at point E, at point P, where the x coordinate is E, you can really just put E in, because you're finding the gradient at a point, right? What's the point? The point is P. What's the x coordinate there? That is E. So you can put that in. ln E is just 1, which gives you a gradient of 2 upon E. This is the gradient, remember, for the tangent. For normal, for perpendicular lines, you have m1 into m2 is equals to minus 1. M1 is 2 upon E. into m2 is equals to minus 1. So m2, which is the gradient of the normal, would be minus e over 2. So it's kind of like looking at the negative reciprocal. You can think of it like that, right? Um, just by the way, it'll be easier if we just figure out the points of P. What are points of P? We know the x coordinate is E. If you put it inside the equation, ln E is 1, 1 square is 1. You know y is 1 as well. You can use that to find out the equation of the normal. So y minus y1, we'll just take this. M was minus E upon 2. X minus x1, we'll just put E. So there's a minus sign in between. Right, you get 2y minus 2 is equals to minus ex plus e square. That's what you get. This is the equation, you could say, of the normal. To find the coordinates of q, you just put y0. So that will be minus 2 is equals to minus ex plus e square. That makes ex is equals to e square plus 2 upon e. And if you pop that into your calculator, you'll get your answer. You're getting approximately 3.45. That will be your answer for x of q. And obviously, you could just leave this answer at this point where it wasn't an exact form. The question is not specifying, so it doesn't really matter. Okay, so you need to show that the integral of ln x is such where c is a constant. Okay, integral of ln x dx is equals to x ln x minus x minus x plus c. Okay, so the integral of ln x. Now that's oh, I think I'm missing something here. वो क्या रहा है इधर? Now you could prove it by integrating this, but I don't really know how to integrate a logarithm. You could remember this integrals and differentials are anti-functions. So if integrating ln x gives you x ln x minus x, differentiating this should give you ln x if you can prove it through that as well. So let's take x ln x minus x plus c, and if the differential of this is ln x, then we have proved it, right? What is the differential? Here you'll have to use your product rule, u prime v plus v prime u. What is u prime? U prime is 1. What is v ln x plus what is v prime? V prime is 1 upon x. What is u? U is x. Here it doesn't really matter what you keep as u or v because it's product rule. It's just gonna add anyways. Anyways, minus x ka differential is 1. Constants ka differentials are always 0. This gets cut. This gets cut. You have ln x minus 1 plus 0. Okay. Oh, sorry. So the x values here get cut, admittedly, leaving you with a 1, right? A plus 1. That's important not to forget that. Once you got that, then you can cut this, leaving you with an ln x. Thus, you've proved that if you differentiate this, you get this. And hence, you've proved the particular equation. Okay, last part of the paper, a very long paper. Using integration by parts or otherwise find the exact, so they don't want it in decimal places, they'll probably want it in terms of E or so or ln. Find the exact value of the area of the shaded region between the curve, the x-axis, and the normal PQ. What is that? Oh, they are in fact given it to us, which is perhaps why it'll be more helpful for us to keep our value of q in an exact form, because they want the area in an exact form. So q would be, if we can, I can write it as this. I can even split it up and write it as e plus 2 upon e, I believe. Yeah, and 0. They want the shaded area. Now you can find out this area very easily. What is this area? If this is e and this is e plus uh, 2 upon e, then this particular base is e plus 2 upon e minus e. It's like e plus 2 upon e minus e. This and this cuts, which leaves us with the base of 2 upon e. What is the height? The height would be the y value of p, right? And the y value of p is given as 1. Hence, the area of this would be half, because you can see it's really just a triangle. Half into base into height, cut, is equals to 1 upon e. So this particular area is 1 upon e. We have that. We now need to integrate this from this point to x is equals to e. But we first need to figure out what is this point. And to do so, we'll need to figure out where is y 0. Y is equals to ln x square. Where is y 0? Okay, y is 0, I believe, whenever you have ln 1. So ln, let me drop this. Okay, so ln 1 is 0, right? So ln 1 square should also be 0. So this would be when ln 1 happens square, which means that when x is 1, y is 0, which helps us, because if you go back to the equation, now you know you need to integrate from 1 to e, and then you just add 1 upon e to get the exact area. So you need to integrate this. You need to integrate ln x square from 1 to e dx. And you have to do this using by parts. Okay, so now normally you figure out which you have to keep something as u and something as v. Here, I mean, basically you can look at this as in this form. You have ln x multiplying with ln x. Now, normally that's how you used to have it in by parts. It was kind of like your product rule for integration. Here, incidentally, both u and by both the first bit and the second bit are the same, but that doesn't matter. You can still use your by parts formula, which I don't remember, but I believe it's given in the MF9. So yeah, so by parts was u into dv upon dx, and they give you this formula. So where was I? Yeah, so one of this is going to be equals to u. One of this is going to be equals to dv upon dx, right? And now it makes more sense why they made us do the previous part. Anyhow, u is ln x, and if you look at the by parts formula, you'll need the differential of u in the formula. So let's just get that over with right here. The differential of u is 1 upon x. So you got information for u and its derivative. dv over dx is ln x. If you integrate this, you get v. Now we can't integrate ln x, but that's where the previous part comes in. They already asked us to show this, which is why they asked us. Normally in such questions, there is a link. So the integral would be x ln x minus x. You won't add c because you do have your, you only add c when you don't have your limits. You do have your limits in this case, so you won't bother adding c. So it's just, so here v would be x ln x minus x, because you know that's, you've already proved that, and now you have the information for what, for v and its derivative. What is the by parts formula? Uv minus integral v du over dx. So uv minus integral v into du over dx. This is being integrated with respect to x. V du over dx. Yeah. So we can start putting stuff in. Uv. What is v? V is x ln x minus x, and this is u is ln x minus. Is this uv? In fact, yeah, it is uv. Sad life. It's not as nice and as I thought it would be. Anyhow, minus, and you have to multiply v with du over dx and then integrate it. So since du over dx is 1 upon x, I'll just try to do this in my head. So you just multiply this. Ln x into 1 upon x would be ln x, minus x into 1 upon x would be minus 1 dx. You need to integrate that. Let's just try to simplify stuff. So x ln, again remember, you can do this. If it was ln x plus ln x, you could have written this as ln x square. However, in this case, if it is ln x into ln x, you can only write this as ln x whole power square. You don't have that nice property applying here, so don't get that mixed up. Minus x ln x. So yeah, you do that. You have to integrate. You have to integrate ln x and 1, and we can integrate ln x. We already know the integral to ln x from our previous parts, which where ln x was x ln x minus x. So so x ln x minus x, and the integral of 1 minus 1 is just x. Right? Then you try to simplify life. You very bad attempts to simplify life. You can simply write this as plus 2x. Okay. So now you have x ln x square rather minus 2x ln x plus 2x, and this is taken from 1:e, I believe. What was it? Yeah, 1:e. So e, if you, let's put e first. E ln e is 1, so that is just 1, minus 2e ln e is 1, so that is just 1, plus 2e upper limit minus lower limit. Remember, wherever ln1 is 0, so this would be 0, this would be 0, plus 2 बच जाएगा आपका बस. Right? Now let's do some simplification. This is 2e, this is minus 2e. You're left with e minus 2. That should be your exact answer. Thank you for watching. Finally, the paper is over. I spoke too soon. Sorry. This is not this is not your complete answer for the area. This is your answer for this. You still have to add it to 1 upon e for the triangle that we calculated pehle. So much for the dramatic exit. You just add 1 upon e, and now this should be your exact answer. Now I can say thank you for watching.